started today is our test, which is coming up next week. You should have gotten an email from me this morning that had your points. If something looks wrong in that, I wrote a program to write those emails, so it's possible I got something wrong. So please let me know if you do see something that looks incorrect. But and there was also a few things that got submitted that I hadn't been able to grade that didn't get the points in there. So it's possible that if you submitted something and I had not graded it, your points will go up very soon. But there were a few things that I hadn't gotten to. In the points note, you don't have to get the maximum number for every category. You just need to get that 70 will get you a C, 100 is, A+, so there's kind of a range that you can aim for. If you got every point in every category, you'd get 112 points. So you don't need to get every category completely filled out. But with that being said, so if you're really struggling with the labs and you don't get 25 lab points, that's fine, as long as you're getting most of your participation points or most of your homework points, and you feel like you'll do okay on the test. The test, the way I'm planning on doing the test is it'll go live on the 22nd. So on Canvas, it'll all be on Canvas. If that's an issue for you, let me know and we can work something out. There won't be a time limit, and I'm not going to try to restrict you from using anything, but it is just one attempt. So once you start it, don't close it, because that'll be it. If that does happen, let me know and we can work something out, like on accident, but it is going to be just one attempt. But it's in limited time. I encourage you to use your book and your class notes. Okay, the test, so my plan, I got a question in the chat, so I'm trying to kind of keep it. You will have time in class to do the test if you want. So we will not have class on Tuesday like normal. That will be a test time. You do not have to take it in that time. It will be available starting the 22nd until the 28th. So you will have a full week to do the test. It's in limited time. Just once you sit down and start it, that's when you do it. Its format, there'll be 10 multiple choice questions. I'm just finishing those up, and then 7 short answer questions. You will only have to do 5 of the short answer questions. So I will take the top 5 highest scores from the 7 questions, so you can skip some. Part of that is so if there's a lab that you didn't do and one of those questions is about that lab, you can skip that one and it's fine. I think if there's anything else. Yeah, it's open book, open notes. The best way to study is by doing the in-class work, doing the labs, doing the homework. So if you are worried about balancing studying and getting your points is going to be the best way to study. So that's kind of the good news. I'm really trying to base it off of what we've done in class or what you've done as for your labs. I did send out a study guide that had some of the types of knowledge that I think we've built over this semester. So that's a good place to start. That's where I'll be pulling questions from, will be things on that study guide that relate to the topics we've covered in class. So I don't think there should be anything too new or scary. And like I said, so the 22nd, we won't have class. I will be on this Zoom link if you want to do your test then and you have questions for me. You don't have to do it in that chunk of time. Does that make sense? I'll send out an announcement about this too. Any questions about tests or points or anything?
So are the badge points due on the 22nd then?
Yes.
Okay. Okay.
Thanks, Brooke. Yeah. So, and I think all of the in-class assignments and the homework have a due date of the 22nd. So those will, I think, so those will actually close on the 22nd. You won't be able to do them after that, but other things will stay open. So yeah, badge points are due the 22nd, then you'll have a week to do the test. Any other questions? Okie doke. Let's go ahead and get started then. And please feel free always to send me an email if you're confused or worried about anything. There is still time, wherever you are, there is still time to get enough badge points. And this is just the first third of your kind of class credits. So the planetary science badge is 30% of your grade. So if you didn't quite figure everything out for this part of the semester, that doesn't mean you failed the class. You're still doing okay. Okay, so let's talk about our crazy solar system. So last week we talked about the Earth and the Moon. Now we're going to focus on the other terrestrial planets. So these are the planets that are made, the rocky planets and the inner part of our solar system. So a lot of you guys have done the Scale Model Solar System Lab, which has been a ton of fun to grade. I love seeing the different models you have made. And what you've noticed is that the inner planets are a lot closer than some of the outer planets, and those inner planets are our terrestrial planets. So there are 4 of them: Mercury, Venus, Earth, and Mars. These are to scale in terms of radius, but obviously not in terms of separation. They are not this close. And we're gonna kind of talk about each one individually and how they have some similar properties as well as some pretty different properties. So just kind of in general, all the terrestrial planets are smaller, rocky planets, and they're the closer ones to the sun. They have some similar surface features. All of them have impact craters, and all of them have some signs of volcanoes and volcanic activity. I will note, last class we talked about how only Earth has plate tectonics. This is true. Earth is the only planet with the plate tectonics. Your reading did talk about the other planets having tectonic features. So what that means is the other terrestrial planets do not have plate tectonics, but they do have a molten magma core. And so the surface of those planets is kind of like one giant tectonic plate. And it can bulge as the magma pushes up, and it can kind of crunch as the magma might move away from the surface in certain areas. There will be tectonic activity, but it won't be plate tectonics. It's just that one giant outer plate either getting pushed out or kind of shrunken in with time. So not multiple plates jutting against each other, one big plate is kind of moving. So that's one little difference. Earth is special, it has plate tectonics. The other 3 planets, terrestrial planets, do not have plate tectonics, but they will have features, tectonic features caused by the inner molten layer pushing out or scritching in at different times. The really cool things, besides learning about other planets, the terrestrial planets can tell us some about how the solar system formed and potentially how life developed and changed on Earth by looking at why didn't life develop and change on these other planets. Although some of you, we will talk about this, I promise, some of you sent me the really cool discovery that came out yesterday. So we'll get to talk about what's happening on Venus soon. Who knows, maybe there is more life in our solar system. We can also use the other planets for models for how climate might evolve on our own planet and might have changed over time. So the first planet in the terrestrial planets is Mercury. Mercury is also the smallest of the terrestrial planets. It's the closest to the sun, which means it has the shortest year. So it's spinning around the sun faster. You guys might have noticed this back when we did the planet motion activity. We could see Mercury kind of zipping back and forth. Mercury is named after the Greek messenger god because it moves so fast, so it runs very quickly. It's smaller than Earth, so it has a lower surface gravity, more because its mass is lower, sorry, it's smaller, but it also has a lower mass. It doesn't have any axial tilt, so that means it won't have seasons, which is kind of interesting. So remember that tilt, the 23-degree tilt on Earth is what produces seasons. Mercury does not have any tilt, so it does not experience seasons. And Mercury has no moons. Oh, you just pointed out that I have my mythology backwards. Mercury is Roman, Hermes is Greek. So yes, that is correct. Thank you, V. I should get my names correct. Fun little thing as well, like the main probe where we get most of our information on Mercury is from the MESSENGER probe. So MESSENGER is actually an acronym that stands for something crazy that I can never remember, but it's named after that messenger god. I appreciate it. I like getting, sorry, I'm getting like chat and trying to do class, but no, I appreciate you guys. You should interrupt me when I make a mistake because my expertise is in astronomy and science, and you guys have expertise outside of that that is really helpful and makes this class better. So please do tell me when I make a mistake. Okay. As a little kind of sense of scale, this is the Earth, the Moon, and Mercury to scale. We can see that Mercury is pretty close to the Moon in size, so it's a little bigger, but kind of similar, and in a lot of ways, Mercury and the Moon are going to be kind of similar just in their general properties as well, so we'll see that they're in some ways pretty similar. But just as a way of thinking of scale, Mercury is a lot closer to the Moon in size. One of the really crazy things about Mercury is that it is tidally locked to the sun. So it has this weird rotation in orbit kind of thing. So just like the moon, we only see one side of it because it is tidally locked with us. So its orbital period and rotational period are the same. Mercury isn't quite to that point yet, but it's being slowed down by the sun. So every 3 days on Mercury are 2 years on Mercury. So it's a little weird to think about. And just to kind of show this, my friend shared this with me. I think it's really cool. I just need to get my flash working. Sorry, I should have done this before. We can think about how weird a day would look on Mercury. So if we were on Mercury, we'd see the sun rise, and it would just kind of sit there for a while as we also traveled around the sun while we rotated, and then eventually it would set. So days and years on Mercury are pretty weird. So to show that one more time, we get a sunrise. It just kind of hovers there, stays there for a while. And then we'd see a sunset. Because we have that nice locking between the time of a day and the time of a year, so that was 1 year. Depending on where you are on the surface of Mercury, you might get 2 sunrises, you might get, the sun might come up for a bit and then slow down and then come back up. You might get 2 sunsets, or you can just get the sun staying up longer. So really cool the way that gravity from the sun, tidal forces from the sun have kind of slowly changed the time of a day on Mercury to get it closer to the time of a year. Mercury is, okay, so I got another question about the temperature change. Mercury does have a pretty crazy, because of this tidal locking partially, and also because Mercury doesn't really have an atmosphere, the temperature range on Mercury is pretty crazy. So it'll get really hot because it's closest to the sun, but the side that's away from the sun will stay away from the sun for a very long time, and there's no atmosphere to hold heat in. So as it faces away, it radiates the heat away, and it gets very, very cold. So I think there's something, I don't have the exact numbers in my head, I'm sorry, but I think there's something like a 500-degree temperature change between the side facing the sun and the side facing away from the sun. If you want to explore more of this, I would encourage you to check out the Planetary Atmospheres Lab, which digs into this a little bit more and has the actual numbers. But yeah, the changes in temperature on Mercury are pretty crazy, and it's partially because of this tidal locking as well. So one side is constantly facing towards the sun, heats up a lot. The other side is constantly, or not constantly, but facing away for a very long period of time and cools down a lot. So living on Mercury would be very difficult. Yeah. Any other questions about any of that? Sorry. Mercury is also the most eccentric planet. So we talked with Kepler's laws. The orbital paths of planets are pretty close to circle, but they're actually kind of ellipses that get those slightly oval shaped. Mercury's orbit is the least circular, the most eccentric, with an eccentricity of about 0.2. 0 eccentricity is a perfect circle. 1 would be a parabola that never actually closes in on itself. So still close to 0, but not quite. And the orbitals, the kind of oval that is Mercury's orbit, precesses. So what that means is it's not always in the same place. It's kind of slowly, the perihelion position is changing where it is around the sun throughout time, slowly. So the orbit is actually shifting in space with time. And what I think is really cool about that precession is Mercury is actually close enough to the sun that it's inside the sun's gravitational well. When we get to Big Bang and stuff, we'll talk a little bit more about general relativity and curved space-time. But the precession of Mercury's orbit was one of the first tests of general relativity. So we were able to prove that Einstein's theory of general relativity was correct based on how Mercury moves around the sun. So that was one of the first ways they actually tested that, was looking at Mercury. And now we have a ton of other tests that involve black holes and dark matter and all kinds of crazy stuff. But the first one was just within our solar system. We can actually see general relativity having effect on Mercury. So those are just some general principles. Now I want to talk a little bit about the geology of Mercury. So this is just an image of the surface of Mercury. What we can see, the main feature on Mercury is going to be craters. So similar to the moon, most of the things we see on Mercury are caused by impact craters. I did the question from last class about how many impacts happen in our solar system. I couldn't find a good number for that, but they said there was a major impact on Earth something like every 500,000 years. So major was like it would actually hit. There are things called boloids, which explode in our atmosphere, and those happen about 500 times every 20 years. So there's a major explosion within the atmosphere about, or like not major, but there's an explosion within the atmosphere 500 times every 20 years-ish. There's also about somewhere between 5 and 300 tons of space dust that falls on Earth every year. So this is comets, other meteors that get burnt up in our atmosphere fall down to Earth. So they don't hurt anything, it's fine, it's just like little dust that's falling down, but there's about 5 to 300, we're not sure exactly how much, tons of this cosmic dust that fall on our planet every year. So if you're sweeping up and there isn't smoke outside, you know, there's a potential that some of that dust is from asteroids and meteors and comets, which is pretty cool. So on that note, sorry, little sidetrack, but most of the surface features we see on Mercury are from impact craters. And we can see more recent ones will look brighter, older ones will look darker. This is partially because UV light will actually cause this, the rocks on the surface to darken slightly with time. So there's no atmosphere, UV light hits the surface a lot, and the surface rocks will actually get slightly darker. So really new craters will often be brighter. We can also see ejecta from these craters, and measuring that can tell us about the size of the impact and also the what the surface of Mercury is made of. Mercury has a few kind of major impact events that happened. So one of the big ones was the impact event that created the Calorus Basin, which is shown here. So it's an impact crater that's about 960 miles across. So very, very large. And on Mercury, especially when we have a smaller planet, 960 miles is actually a pretty big portion of the surface. We can see that this happened a pretty long time ago, and one of the ways that we can notice that is that there are smaller impact craters that happened after this large one happened. So this big crater happened, and since then there have been small impacts that have happened in the same location. So you can use the density of crater events to kind of age a surface, and we're going to get to try that ourselves in our activity for today. There's also a theory, this is kind of, we don't quite think it's the case anymore, but initially there was a theory that the calorous impact actually affected the other side of Mercury in something called this weird terrain, the chaos terrain, which this is an image of the chaos terrain. So we can just see it's kind of broken up, it looks kind of crumbly. We're not really sure why it looks this way, but initially they thought maybe it was a result of the calorous impact, but now we think probably not. It's probably something else, but we're not really sure what that is. So there's some weird surface features on the backside of Mercury. We don't know why they're there. Outside of the craters, Mercury does have a few other types of geological features. This is the Enterprise group. It's the longest scarp on Mercury, and they're places where the surface of Mercury is kind of wrinkled. So we think that what this means is that Mercury shrank early in its evolutionary history. So early in the history of the solar system, Mercury was slightly larger, and as it cooled, it shrank a little. And as it shrank, it formed these wrinkles that we call scarps. So you can see the arrows here are indicating a scarp where the surface is getting kind of pushed together as it shrinks. There's also some features on Mercury that are called hollows that look similar to collapsed volcanic tubes on Earth. So we're not really sure what they are, but that's what they look like. So we think they're probably volcanic. Again, they're probably from earlier in the history of our solar system. So when Mercury was still hotter, when it was young, there was probably volcanic activity, which has since pretty much stopped when the Earth was, when Mercury was still cooling and collapsing. There was more volcanic activity, but now that seems to be no longer the case. But we do see these features that look similar to volcanic tubes, collapsed volcanic tunnels. If any of you are cavers and you've gone into the volcanic tubes, I know there are some in Bend. I think there are a lot other places. Those are the ones I've been in. But you can like explore volcanic caves. You could do that on Mercury as well if you brought oxygen. Yeah, this is another image. So that was a scarp. This is the hollows where we can see something collapsed, and we think potentially similar to volcanic tubes on Earth. Just more images because it's cool. These are all from Messenger. We can just see again, looks like potentially something collapsed. It's not a crater event because it's not that nice round shape, so it had to be something else, potentially volcanic. Okay. Mercury is also pretty weird on the inside, so we've been talking about the outside. We know this based on, like, we can't measure earthquakes on Mercury because there are no plate tectonics. So we get an idea of the interior structure of Mercury based on how the gravitational pull, as Messenger flew around Mercury, it could measure the gravitational effects, and we can kind of get an idea of what's going on inside of the planet. And what we've learned from that is Mercury doesn't have much of a mantle, but it does have this giant core. So about 70% of Mercury is core. We don't really know why that is. There's a theory that there was a really large impact early in Mercury's history that made it lose its outer layers. So it like shelled Mercury, which is insane to think about. We don't, like I said, we don't know why this is. Often when we don't know an answer in astronomy, we throw a collision at it and see if that helps. But just a weird fact about Mercury is that it does have this 70% of its interior is a solid core, or like a core type, is core and not mantle. Whereas in Earth, we're pretty much all mantle, and Mercury, it's almost all core. Okay, so you all are probably sick of listening to me talk, so let's take a break and get to do some of this science by ourselves. So on your day 6 assignment, we're gonna start with this aging surfaces activity, which will let you use cratering events to try to find the ages of surfaces. So you'll get to work with images of Mercury as well as Venus, Mars, and Earth. to try to figure out the history, the geologic history of these planets based on how these look. I did not fix this. So, okay, on question 4, the image is wrong. I am sorry. I should have fixed this, and I did not, apparently. So if you get to question 4, you can just skip that one and not worry about it. We'll discuss it together as a group. Okay, so you can submit without answering question 4, and you'll get your full participation points. I am going to, so now breakout rooms should be open so you guys can work on this together, and I will pop around